Okay. We have an AP chemistry test on May 7th. That is 5 weeks of content or of time till we take that test. So I know you're in other AP classes, and that's fine. You chose that. My advice to you is that you should start review. The best thing you can do to review is go to the AP classroom and watch all the unit videos. Just start at unit 1, video 1, and work your way through. They will have a little bit of content and then review questions. If you watch all of those and do every practice problem they give you, you will be pretty well reviewed for the exam. But you can't do that in just like 3 days of cramming. If you don't study for the AP test, you literally have 0 chance of passing it. It is not like the AP bio test. There's no writing or BS available. It's math. Yeah, so a lot of people think they'll do okay because they didn't study for the AP bio and they passed. That does not work. I've had kids get a 5 in bio and a 1 in chemistry. So if your goal is to take and pass the AP test, start to review now. You have, it's a month from this Friday, essentially. Not number-wise, but week-wise. I do not think that most people in here will pass the test. That's just my blunt assessment. I think a lot of you know you have no chance and you won't take it. But some of you do have a great chance, and I think you'll do okay. But yeah, I'm not worried because I don't have emotions like that, but I do not. I think this will be my lowest I've had in 5 years. Really? Yes. No. It's fair. It might not be loving, but it was 6 or 7 years ago, and we averaged a 1.42. That was just, I don't remember. I don't remember. Yeah, a couple passed. Okay, so that's my advice to you today. Well, also, by the way, the test we're going to take is on Thursday. And then we have 2 more chapters after that, and we're done. One of them's pretty short. One of them's not super long, but not short. Okay, so today we'll do a practice buffer problem, and then we'll do something that really confuses kids quite a bit. But we're going to give you a situation, and you have to tell us whether it's a buffer. All right, so I can't remember if it's this way. Nope. Hold on. Yes. I am on the roads a lot. Yep, it was good to see you. Okay, here we go. Just see if you remember how to do this. A buffer is made by adding 0.3 mole of that and that to enough water to make that. The pH of the buffer is 4.74. When I give you pH, that sometimes gives you a heart attack. Calculate the pH of this solution after the addition of NaOH. And then there's the Ka. This is definitely something we did before the break. Definitely is something you should be able to do. You may want to turn that in.
The library? This is not mine. Right?
That definitely looks like a Chromebook. Whew. Who needs more time? Okay. It's possible. I don't know. Did you feel like we were stalking you in St. George? I have no idea. All I said, or all I knew, we got out of the car and Derek's like, we just passed Grace Johnson's minivan. Okay, creeper. Like, how do you know that? But then that park, I don't know. I was not comfortable on this trip because people down there don't do anything to stay safe. And that was weird. Yeah, that's good. I drive a white Honda Odyssey as well. We bought it right before her parents were going to buy it.
Really?
That's what your mom told my wife. Yes.
Is this the Henderson?
Yep.
I'm not gonna pronounce it right.
Hasselback.
Hasselback.
What is this?
Oh, yeah. Judah puts that.
Judah. That you're going to get a U.
Not allowed to vote either way.
No,
I have to vote there.
you don't get a vote either one.
Yeah, you don't.
I just probably get it.
I hope we're still left there.
Only Judah will pay me.
It's time to remove Judah from the chat.
I won't do it again.
Judah has left the chat. I don't think I got this.
I think only Cooper can remove it.
All right, here we go. So we have that, whatever. The pH is equal to what? Well, the now, do I even need the negative log of Ka? Okay, whatever. All right, what's next then? Plus, what is the, just this piece, what is the negative log of the Ka?
It's what?
It's like 0.02.
When you type that in, you should get what? You should get that number. It's the same. All right, plus the log. So we had the base is which one?
The second one.
They're both 0.3, so it doesn't really matter. Did I add acid or did I add base? I added base. So the base should go up if I add base, right? So this would be 0.32, is that right? And the acid should go down 0.02. So we're ready to roll. What do we get?
4.8.
Everyone okay with that? 4.8? It's okay. 4.8 it is then. No, I'll never do that again. Yeah,
Really?
Oh,
Why are you adding 0.02? Oh, I see.
because I added 0.02 of base, so it goes up. 0.02 of acid was neutralized, so that goes down.
So because we added to the base, we know the acid is neutralized.
We know it neutralizes acid and releases the conjugate base.
So if it says acid is added, then
Yep, we'd have 0.32 on the bottom and 0.28 on the top. If we added acid, it would be reversed. All right. Can you guys, like, I'm going to assume you can.
Yeah.
All right. So buffer problems, if you can do finding the pH of buffers and finding the pH or after additions of acids and bases, you got a pretty good idea of what's coming.
I have the
The Henderson-Hasselbalch equation, sure, I'll give you that. Okay, this is super important. So here is the question. Are these four solutions, I don't know why I went from dashes to whatever, but we're asking ourselves, is this substance a buffer? This is really, really important because the AP test doesn't always just say a buffer solution was produced by the addition of. It will just say you got crap mixed together and expect you to know everything about it. That's how it's going to come to you. So here we go. Will you take a minute, work with you and your lab partner? You pick two, your lab partner pick two, and see if you think they are buffers. And then we're going to talk through each one of them. If you don't remember what a buffer even is, that is a problem. But a buffer is when there is a weak acid and its conjugate in the solution. Okay, give it a shot and see what you have. I'll give you 4 minutes to just think through it on your own real quick.
Think about it for like 10 seconds.
Okay.
How do I thumbs down a message?
What?
Just trying to figure out how to put a thumb down on.
There's no
You
broken
can just
heart.
do the emoji.
You can just say at Judah.
I am thumbs downing. Wait, that's the thing. You can like this part.
Or like,
Yes, you can. I just did it. Yeah, where I hit it.
Okay, most things I hear have nothing to do with what I'm asking. So should we just do it? Okay, it's more complicated than it sounds like half of you gave it.
Wait, what?
Because I heard, well, this one's not because it has a strong acid. That is not a true statement.
What?
What? It's more complicated than you think. Now, it may or may not be, but we can't just say, well, this is gone, and this is gone because there's a strong acid. That is not true at all. And we'll learn why. And that's why this is all caps. This is really important. Okay. So the first thing I need to do is figure out the moles of both things. How many of you tried that? So that's your wheelhouse. AP Chem, it's all about moles. We can't do anything unless we know about the moles. So here we go. 0.03 times 0.2. Why 0.03? All right, good. That's the volume in liters. This is the molarity. So what do I get? Moles of, I don't give a crap about the Cl. I'm going to put H plus. You with me? Okay. Then I need moles of this. 3 grams of NaF. So I have 3 grams. You don't have to do a picket fence anymore, but you can. 1 mole NaF. And I have 42, right? 23 plus 19.
Yeah.
You with me where I got those numbers?
Yeah, that's great.
Did you say I had it wrong? Okay. No, it's 19 and 23. And which part do I not care about here? I don't care about Na. Now I know I did NaF here, but it's a 1 and 1, 1 when it breaks apart. Okay, So I'm going to say F minus. Because this is the trick. Yes, I put NaF with the strong acid, but chemistry will make the weak acid. And that's what we care about. So now that I have these two things, I will make HF, which is a weak acid. The amount of HF moles is equal to the smaller number. So, all right, in my beaker now, I have 0.006 moles of HF. How much F minus do I have? All right, good. F minus equals the difference. Whatever, did I do that right? Okay. And did someone do that already? 0.065. No, say that again, actually. Yeah, you just take the two numbers, take the smaller one and subtract it from the bigger one. Yeah, you don't want this to ever be negative. 0.065 moles of what? Do I have a buffer? Okay, the answer is yes. I have a weak acid. And I have its conjugate base. Did I add the two of them together? No. I took a strong acid and a salt and I added them, and chemistry happened and made the buffer solution now. Judah.
So if there's something like this one, your test debate, will it say justified?
It probably won't say, I mean, I don't know, it could, but just doing the math, which you would have to do as part of the problem, is the justification. But sure, if they said justify, then yes, you would say, because I have a weak acid and it's conjugate base.
Does it have to be its conjugate base?
Well, the way this problem works, yes, because I would have put the two things, they would have made each other. So there wouldn't be another thing, but technically, sure, it could be another conjugate base, but these problems, they will always match. Okay, how could I find the pH of this solution? Not the concentration of H plus, there isn't any. Yeah, it's the Henderson-Hasselbalch, it's a buffer. So there's something missing. What is missing? The Ka. And I don't remember, but we could, if I just say the Ka of HF, I'm just making it up, we'll say it's 2.8 times 10 to the negative 4. Okay, find that pH for me. This is still A. All of this? I agree. Try teaching it. The only measurements you care about are right here. Yeah, the Ka, I wrote it right here. 2.8 times 10 to the negative 4. I didn't write the second half because I want you to know it. Is there a problem? Oh, sorry. Okay, what would be in the numerator. David Hasselhoff's a bad A. And then we have on the bottom, for my test, yeah, and the AP test, it's like 5 pages long, sort of. Yeah,
How would we like, how do we know which ones, like, we just gotta know where they're at?
you gotta know. We'll study it. Okay, what's the answer? We'll look at it. 4 point what? Feel pretty good about that. So was it a buffer? Yes. It's a buffer because chemistry happens and then I look at the solution. Okay. Yep. What's that? Okay, yeah, here we go. B, is B a buffer? This is one that, yes, you should absolutely know in 2 seconds. It already gives you weak acid and already gives you the salt. So that one's a yes, like for sure. I see it. Yeah, you already said it in your nice deep voice. You're like, B is the obvious one, like 10 minutes ago. And it's right. Go ahead.
Then, I mean, it could still be something else, but if it was like NaCl, then it.
If it was NaCl, it would not be, right? What's that? It is a salt. The Na would have nothing, and Cl is the conjugate base of a strong, so it wouldn't do anything either. Okay.
B is right. B is a buffer.
B,
So is A.
B is a buffer.
Oh, I was just basing my answer on there. I didn't want you to have got it.
It's okay. Garrett is very bright as well. I love that Garrett just did it in 2 seconds, and I love that he was wrong because they look easy, but they're hard. They are hard. Okay, if it just gives you this, just straight to Henderson Hasselbalch and you move on. Like you would have to get moles and moles, but we're good. So I'm not going to do B, but it gives you a weak acid and the salt that has the conjugate base. Okay, looking at C, 0.2 milliliters of HCl and 20 grams of NaF. So this is pretty similar. So the chemistry says that I would have this and this, they would react to form a little bit of HF, right? And a lot of excess F minus. So moles would be 0.0002, right? Yeah, because that's 0.2 milliliters.
Oh, that's right.
That was tricky. I had to think it out as I did it. Then 20, 40 seconds, 10, 21st, I don't know, 0.48, 0.47. So how much acid do I have? A tiny amount. You okay with that? And this is essentially the same number, right? 0.47 minus 0.0002. Well, it didn't. But 0.4698 and 0.47, I was just saying they're really close to the same number.
I get base. Because mine's still.
It's the acid is always equal to the smaller of the two numbers. Because I can't have more acid than I have of the smaller of one of them. So there's only 0.0002 moles of H plus. So that's the maximum amount of acid I can make. Okay, then we could plug that in if I gave you a Ka. You all right with that? Okay. Because I was lazy, I guess. You want me to put one? All right. Okay, so first discuss with your partner if that is a buffer. C was yes. D is going to be no. Garrett is right.
I said that before you.
Cooper was right. He told Garrett. Why is D a no? All right, good. Strong and strong. It's a strong base. Oh, I'm going to shoot myself in my. Yeah, since chapter 2 for the 20 millionth time. You got to know the strong acids and bases and KOHs. Family 1 bases, and then the lower hydroxides in family 2. Okay, look. So this is not a buffer, but could I calculate its pH? Yes. And this is the problem. We've done hard stuff, so you forget what should be easy. And this one should be easy, so let's make sure we review it. So there was no molarity, but I made it up. So we find the moles of both. So I have it's 0.05, right? 0.1 moles of H plus. And I have 0.03 Okay. Did I do the math right? Okay. So now I come here and I need to know, I have this much. I need to know which one I have excess of. I have excess H plus. How much of it? All right, we okay with that so far? All right, now that's moles of H plus, but pH is equal to negative log of the concentration of H plus. So this needs to be divided by 70 milliliters, which is that right? Right? So what do I get? 1. So this was really bad numbers to choose. That was my mistake. But we would do that process. That was it's really concentrated. We'll just put it that way. Okay, but pretend it didn't equal 1. You just take the negative log of that. Are we okay with that? Yeah.
But with the strong acids and bases, like right, we completely dissociate. Doesn't that mean they like neutralize each other? So
They do neutralize, but if there's excess of one or the other, then there's excess. Yep. So anyway, if it's then it would just be a pH of 7. Okay. When you have a strong acid and strong base, you simply find whether H plus is in excess or OH is in excess and take the negative log. If it's OH, Tolman's always on this one. If it's OH, we subtract it from 14, right? You've caught me on that like 3 times in a good way. When it's really POH, but I teach it like it's pH. They're like, hey, you got to subtract. Okay, here we go. Something maybe.
Can I ask a question?
Sure can. Yeah, go ahead.
So, with those previous equations though, so if we had more of the base, and more of the H plus than like F minus, would that not be a buffer?
Yeah,
Would it
if you
be a
have-
buffer, or F minus would be a buffer?
Yeah, that's a really good question, and make sure you kind of put this feather in your cap. If you have excess H plus, that's the only math you do. Because sure, there is some weak acid and all that in there, but H plus or excess OH is way more important to the pH than a buffer would be. Does that question make sense? Let me find one of these we can do without me. Oh, well, there's your exact question right here, ironically. So if you, this is one from previous years that has all the answers. But I gave them, it was in 500 milliliters. The NaF, you had 0.2 moles. You had 3 moles of H plus. You would do right there the math, which one's in excess. You would take your 3 moles of H plus and subtract your 0.2 moles of F minus. You get 2.8 moles of H plus as your excess. That means it's definitely not a buffer. It's a very strong acid now. So you would just take this now and divide it by 500 or 0.5, and then you'd get a crazy, crazy pH on that one. Yeah, sort of, but not. Sure, when I make up numbers, yeah, they are. So yes, if you have excess H plus, that is what matters way more than whether it's a buffer or not. These are the same, right? Okay. Well, that was cute. Okay, here we go. My handwriting's not very good, but this is the summary. So SA and salt are mixed. SA means strong acid, and we could do the same thing for a strong base. If conjugate base is excess, then you have a buffer. So you got to find the moles, find which is in excess, and that will tell you whether it's a buffer or not. All right, if your H plus equals your conjugate base, that's just a weak acid. We didn't do one of those. That's where we use the old thing where we go X squared over initial, solve for X, and that's the concentration of H plus. We can do one of those before we test. Yep. So we just end up with like 20 milliliters of some molarity that we don't know of HF, and we can go from there. All right, then if H plus is excess, that's simply a strong acid. Now, each one of these, it tells you what to do. If it's a buffer, we use head. Did that shut off or did my brain shut off? Okay. That's a good question. All right, so if it's a buffer, we use Henderson-Hasselbalch to find the pH. If it's just an amount of a weak acid, we have the Ka equals X squared over initial. We solve for X and take the negative log of it, and that gives me my pH. That's for this one. Yeah, it's like an ice table. We don't have to do the ice table because it's what it simplifies down to. And then once again, if H plus is excess, you have a strong acid. So pH is the negative log of the concentration of excess H plus. 100%. They are extremely tightly woven together.
So the reason strong acid is like HCl
because I had H plus excess. If I ever have just straight H plus, that means whatever it was with is broken off, which means it's completely strong. Now, yes, again, there'll be some weak acid in there, but it's comparatively to just straight H plus, it's almost nothing. Okay. Are we sort of all right with that? These are definitely on the exam and definitely on the AP exam. All right. What is the pH of a solution of 250 milliliters of 1 mole HCl and 10 grams of LiCN? The Ka of cyanic acid is what that's called, is 4.9 times 10 to the negative 10. Fire away. This is at a level we should absolutely be able to do now. I don't know. It's not 7, 19, 14, 33.
Yeah, that's a base.
Huh? It's a conjugate base because HCN is a weak acid. You don't have to have that memorized. What?
We have to memorize this on that.
Right. And it's not on that list, so it must be a weak one.
I didn't know CN would ever be like that.
Yep. Just cyanide
Would you use 10 times 33? Eli is a strong base. I forget. Grams times.
divided by.
That's what it is.
What's that?
Eli is a strong base, so that's not fun. I don't know if that is like 33.
Li has nothing to do with anything.
You said the family one.
I know, but did I give you lithium hydroxide?
It's only a family ones with an OH.
Right. Is it as warm as it looks out there? Finally a warm day. Soccer game this week?
No.
Oh,
We
sweet.
actually have our first,
Whenever there's a home boys soccer game, my track practice attendance is inversely related.
Really?
Oh, yeah.
Well, that's good for you. This whole week.
Yep. So here's your attendance. Here's my attendance. Just for the girls. Not a lot of boys.
Oh, professional soccer
Yeah,
players.
they're like, I'm a bounce.
Oh, was-
Did anyone have part 1 yet? I love you, Nisha. What's 10.30? Oh,
Oh, it's between roll fighters.
is it a buffer? You dang well bet it is. It has a weak acid and it has the conjugate base. It wasn't given to you directly, but chemistry made it for you. That's the whole point of today. We put things together, chemistry happens, and then there's more chemistry once that's formed. Okay, so now how do I find the pH?
So the H plus will always be equal to the.
Smaller value, hopefully is what you're about to say. Oh, that, yeah, because that's where the H came from. So my pH equals negative log of 4.9 times 10 to the negative 10 plus log, which one is the base? 0.05, 0.25, and we'll put the equal sign right here. And it is what? 8.6.
Can you just remind me of something one more time?
Yes,
Why don't we use the point versus and why do we subtract it and use the point?
because
Just because we know it's combining with the CN.
we know it's combining, so it's removed.
So we know it's been used, we use the swapped over.
Mhm.
Okay, thank you.
You're welcome. Once the solution has reached equilibrium. So by the way, this shouldn't be a base. It's okay that it was, because I just make my numbers up, right? But on the AP test, if they give you a buffer that's made from a weak acid, it should have an acidic pH. Under 7. All right, once the solution has reached equilibrium, 10 milliliters of NaOH is added. This of 1 molar, sorry. So how many moles is this? You're right, sorry. And that's base, right? So everything's the same. pH equals negative log 4.9 times 10 to the negative 10 plus log. The B goes where? Up. It better go up because then we'd have a negative number and life would explode. So 0.1, what was I? 0.06, thank you. And then I went down to 0.24. And what do I get? What is it?
I was gonna ask, so it didn't matter that you added a strong base?
No.
No.
It matters, like whether I'm going to make it more basic or acidic. But yes,
But if it was Na, whatever.
no, it'd be really close, but this number would change. It would change in a smaller way.
Wait, so is it true that like there's something?
I added 10 milliliters of 1 molar Na instead of NaOH. It wouldn't go from 0.05 to 0.06.
No, because that would, but the bottom wouldn't change,
Bottom wouldn't change.
if I'm understanding your question. Judah,
What your is a 0.01 mole base.
right? This right here is 0.01 liters times 1. So this will never add another amount of salt. We have the buffer established, then we want to see how it is affected by the addition of hydroxide or H+. It'll never add another salt. Yeah. All right, well, that was the plan. We had 54 seconds to go. When's the last time I taught everything I wanted to in a day? You can take a picture of that and work through it if you want. It looks a lot like something you might see again. Oh,
Oh, man. Okay, here we are.
Okay,
This is gold.
oh, hold on.
Oh, come here, Davidson. Come here, Davidson. Yeah.
All right, vote for Derek.
Wait, how many people do you
No, no.
That's like 5. Well, I don't know.
I'm not sure.
It's probably 7 actually when you're a senior. I think it's 7. I don't think, never mind, I'm not going to say that.